Okay, nervous system. So, what is your nervous system?
Well, it's your brain and your
So,
brainstem and your
includes
nerves,
your brain.
your nerves,
It also includes nerves.
brainstem.
Yeah. So, what is the purpose? Like, what is the purpose of our brain and our
Like
nerves and spinal cord and all of these different parts? Like, why do we need those?
to help the body function.
Yeah, to help the body function. And what's going on in our brains?
It's like consciousness.
So Luke mentioned this word consciousness, your concept of yourself, your thoughts, memories. That's an important function of our brain. Our brain is what's responsible for some of those things. What else does our brain do? Besides our consciousness and memories and sense of self, anyone know what else? What?
Signal.
Yeah, our nervous system is involved in signals. Really, our nervous system is for communication. It allows for communication between different parts of the body.
Yeah, like it makes your arms move.
Yeah.
And it helps you feel.
Right? Our voluntary movements that we do, we control them starting with the brain. We take in information from the outside and from inside our body into the brain. Okay? And that's all part of the nervous system. So humans have a very highly developed nervous system. Okay? It includes the brain. It also includes other parts, the spinal cord, nerves that branch out from that as well. Also part of our nervous system are our senses, our eyes, our taste buds, right? The parts of our ear that allow us to hear. Those are also part of our nervous system. Sensors in our skin that can feel heat, that can feel touch. Those are also a part of our nervous system. So there's all these sort of different parts. So we have some terms we use when we're thinking about our nervous system. One of those terms is a stimulus. I don't know what is that. What does that mean? Or what would an example of a stimulus?
Well, that sounds familiar. It's like your touch.
That would be an example. So when I touch my hand, that sends a
Signals.
signal. There are sensors in my skin
It's like a
that take
telegraph
this information that I'm touching my hand. They then send that information through nerves up into my brain, where my brain processes that. It says, oh, something's touching me. That happens through these sensors in our skin, through nerves, through our brain, all those things kind of working together. And a stimulus can be more than touch. What you see right now, you hearing me as I talk,
Our senses.
that is a stimulus. It's information coming into your nervous system.
So you
And it gets there by these receptors. Your eyes are receptors. In your ears, you have receptors. In your skin, receptors that can actually take in.
So your
this
stimulus is
information.
just your senses.
Yeah.
You know, it kind of reminds me of
And then-
a telegraph line.
And then this information moves around our nervous system using something called nerve impulses. That's the messages that get sent from our brain to our muscles, from our eyes to our brain, from our skin to our brain.
Because I'm having
That's,
some kind of existential crisis.
and then we also can respond to those stimuli that if I toss this towards Ray,
What is that?
So as I toss this to Ray, first off, a stimulus was coming into his nervous system. Receptors in his eyes saw this remote control coming towards him. The impulses from his eyes went to his brain and said, this thing's coming towards me. He then sent out signals to his muscles, telling them to put his hands up in a certain way, to close his hands to catch it. That's an example of the response. So this is how our nervous system works. Stimuli come in to receptors. They get sent to different parts of our nervous system, and if necessary, a response happens. So here is what we call our central nervous system. Our brain is the main part of that, but also our spinal cord. Where is your spinal cord?
Your back.
It's in your back. It's really important because our spinal cord is one of the ways information gets up to our brain and from our brain out to other parts of the body. It's very important, so our bodies are adapted to protect it. What protects our spinal cord? This nerve tissue. It's protected.
Is it the brainstem?
No. What protects our lungs and heart?
Oh, the rib cage.
Our rib cage. There's a different bone that protects our spinal cord.
Spine?
Sort of, because when people say spine, they could be talking about different things. What do you call these things?
Oh, plates.
They have a name.
Spikes. I forgot. I know.
These bones.
I touch it.
Spine.
Well, sometimes it's confusing when people say the word spine, because inside of here is your spinal cord.
Marrow?
Hold on. Inside this yellow thing, I'll pass this around, is your spinal cord, nerve tissue. These bones, though, are called vertebrae.
Vertebrae.
So there's a whole bunch of these bones. You could see them here. One stacked on the other, stacked on the other. Our spinal cord goes through these bones, so these protect it. So if something hits you in the back, your spinal cord is protected by these bones. They're strong. They're separated by these little discs of cartilage that
Make it like flexible.
make it flexible, that cushion it. Every once in a while, what this is showing here on this model is a bulge in these discs. One very common form of back injury is when these discs get injured, they can kind of swell up and they could put pressure on these nerves. So people could have pain. Like, have you ever heard of sciatica?
No.
This is when you have like shooting pain down your leg. And it often can be caused by a bulging disc in the vertebrae, which puts pressure on a nerve, which causes it to be painful. But these bones of our vertebrae help protect our spine.
I'm an invertebrate.
And branching out the sides of the vertebrae are nerves that take signals back and forth. So I'll pass that around.
I'm an invertebrate.
It looks like a lobster.
Did you know lobsters are
All right.
invertebrate? They don't have
So
a backbone.
this, turn to your next slide, please.
That's a neuron.
So our nervous system is made of billions of these cells that are called neurons. A neuron is a single individual nerve cell.
Neuron activity.
Our brain is made of millions and millions of these neurons that are connected together. So this is what a neuron looks like. It's a cell that has a very unique shape. It's elongated like this because neurons take information from one place and send it to another. So signals come into a neuron through these parts called the dendrites. It travels down what's called the axon to the end of the neuron, okay? And then it can pass on to another neuron. So these cells, all interconnected, form our nervous system. Don't worry about the parts. And our nervous system works basically using electrical signals. Because of different molecules and atoms that are present, messages go from our brain to the muscles in our hand through an electrical and a chemical signal. This is one of the reasons why getting a shot can be dangerous, because it can interfere with that process. Our heart beats based on electrical signal. Our brain works on electrical signals. Messages move through our nervous system using these electrical signals. So the central nervous system includes our brain and our spinal cord,
Cool.
which is inside of the vertebrae, which is being passed around.
Cerebrum, that's what the cerebrum.
And we have learned over time, different parts of our brain do different things. Scientists have learned this over time. Our brain is made of a few main parts. The cerebrum is the largest part of the brain, the part you're probably most familiar with all of those folds inside of it. That's what the cerebrum is. This is where a lot of things happen. This is where we take in information. This is where our memory is stored. It's where our conscious, voluntary actions originate in this large part of the brain, the cerebrum. Down towards the base of our brain and the back of our skull is a part called the cerebellum. No, memories are stored in the cerebrum. The cerebellum is a part that's responsible for coordinating our movement, okay, maintaining balance. And then at the very end, connected to our spinal cord, is this part called the brain stem. And the brain, it's a sort of a continuation of the brain stem. And the brain stem is the part that kind of maintains the parts of our body that keep us alive, like our breathing, our heartbeat, our blood pressure, reflexes. Those come from this part of the brain.
Where does thinking come from?
Thinking comes from the cerebellum.
Yeah, thinking.
I'm sorry, no, the cerebrum, not the cerebellum.
Why is it all like wrinkly like that?
It gives it a huge surface area because there's millions of neurons, and so they're all connected together there. And the pattern of connection
Makes you smarter.
is what gives us our memories. Do you have another question, Tom? Yeah, go ahead.
What if it's like not like that, not wrinkly?
You're dumb.
No, it doesn't. That's not. It's always wrinkly. It's everybody's brain has those folds and those.
I saw a smooth brain once.
Really? Never heard of that.
It was a
I
political
would say
party.
smooth brain.
So over time, scientists have learned
Oh wait, I think I forgot.
what different parts of the brain do. There's one part of our brain that's responsible for our language. There's one part responsible for our vision and hearing and memories. We'll come back to that. And the way scientists have learned this is through people that get brain injuries. So when a person gets an injury to their brain, if it's a very specific part of their brain, it can cause them to lose a certain part of their consciousness or senses. And so over time, scientists have learned when a person injures this very specific part of their brain, they might have difficulty speaking and using language. When a person injures this part of the brain, it might interfere with their vision or their memories or things like that. So scientists have been able to kind of pinpoint which parts of the brain do different things. There's also more modern technology where they can scan a person's brain while they're doing different activities, and they look at which parts are sort of lit up. And so they can locate different functions to different parts of the brain. So our brain controls and integrates all this information. So for you right now to write down, is there anything to write? Yes. For you to write that sentence in your notes, let's think about how you're doing that in terms of your nervous system. So I'm speaking. You see those words. That information, that light goes into your eyes. The back of your eyes is your retina, which turns the light into nerve impulses that go in the neurons to your brain somewhere. Your brain then takes that information, a pattern, and it says, oh, I know what those words say. That says the spinal cord connects the brain to other nerves in the body. Then for you to write your notes and copy down that, another part of your brain says, okay, I need to write. It starts sending signals from your brain down your spinal cord. At some point down here, that message goes down nerves, down your arms, and tells your muscles how to move for you to actually make the shapes of the letters. So your brain is sending that information down your spinal cord, out nerves, to the muscles in your hand and your arm so you can actually write. So that's how you do those things using our nervous system. If you're walking, the pattern is similar. Your brain tells your muscles how to move. It sends the impulse down your spinal cord, out nerves, lower down in your spinal cord, which go to your leg muscles and tell your leg muscles when to move, how to contract, how to move. So you might know what happens if a person has a spinal cord injury. What happens if a person damages a section of their spinal cord? Chelsea?
Doesn't it affect like everything?
No, I wouldn't quite say everything, but you're close. Aisha? They might be paralyzed. And it depends what happens to a person if they have a significant spinal cord injury. It depends on where the injury happens. Does a person lose more use of more parts of their body if their injury is lower on their spinal cord or higher? Right. Because what's happening? Let's say, let's use this person. Let's say this person has an accident and they damage their spinal cord. Their spinal cord gets severed or cut because of, let's say, a car accident. Let's say if it happens here, our spinal cord and other neurons do not heal very well. It's not like a broken bone. A spinal cord doesn't just grow back together and heal like a broken bone would. It basically doesn't heal. So if a person completely gets their spinal cord severed in a certain area, so think about what's happening now. If this person that has a spinal cord injury there wants to walk, their brain still works fine. Their brain says, I need to move my legs. It sends the message down their spinal cord normally. The message travels down their spinal cord. But what happens when it gets here?
It stops.
Yeah, it can't go any further. So the message from their brain telling their legs to move in a certain way, it can't get down to these nerves over here that actually go to the muscles because of this blockage. And so they can't move their legs. They also can't feel their legs because the same thing. Let's use orange. So if you touch a person that has that spinal cord injury on their leg, their sensors still work fine. They send the message up like it normally would to the brain, but it gets to the damage and it can't continue any further. So that message that they're being touched doesn't actually make it to their brain, so they can't feel it. So everything still works exactly as it did before the injury, except there's that gap where the nerve impulses can't go past that. So yes, Chelsea was right. If that injury happens higher, now a person loses use of all of this as well. If it happens up high in a person's neck, it can leave them paralyzed for both their arms and their legs. Again, for the same reasons, because this impulse can't get down to the muscles in their arms, and the impulses can't get from their arms up to their brain, so they have no feeling in their arms or legs, they can't move their arms or legs. The higher up a spinal cord injury happens, the more dangerous.
They'll have to like be in a wheelchair.
Yeah, and sometimes they can even lose the use of like the diaphragm, the muscle that breathes for us, is up here. The nerve that leads to it's up here. If a person damages their spinal cord up here, they lose the sensation and use of their shoulders, arms, wrists, hands, their chest muscles, their abdominal muscles, all of these things. And so they might have to be put on a ventilator that breathes for them.
Or an iron lung.
So this little diagram shows kind of where the nerves go. So obviously the nerves that go to the upper body, they come from this area, the cervical nerves, then the chest and abdomen, and then the lower parts of the body come down here. Jordan, do you have a question?
Can you still talk?
Yeah, it depends. Usually you can still talk. You need air to talk though, so sometimes if the diaphragm is paralyzed, it might interfere with that somewhat. But the nerves that control the neck and the head are the first set of nerves up here. So that would be a very high spinal
To talk, you could just use one of those like electronic voice boxes.
Yeah, but that would be maybe a possibility.
I think it just does in your mouth, not your ear.
All right.
No.
All right. So we'll come back in a minute. Oh, no, we won't. All right. So there's lots of different diseases that can affect the nervous system. We'll talk about a few of them. Meningitis is one. You might be vaccinated against meningitis. Sometimes people are. Oftentimes when people, if they're going to college, they have to be vaccinated. This is an infection of the brain, of the membranes and the fluid that's around the brain. And it can spread. Sometimes from person to person when people live like in close proximity, like in dorms and so forth. So there is a vaccine for meningitis that helps prevent people from getting
You
bacterial
ever heard of
meningitis.
a lobotomy?
Andrew, did you have something to
I
say?
had meningitis before.
Oh yeah, and it does happen. Do you say multiple times?
But that's because there's inflammation in my brain.
Yeah.
Histamine. Compensate for that, I take Advil and Benadryl, since those are not antibiotics.
Right. Those are anti-inflammatories, right?
Yes.
Because if the lining of the brain is inflamed and swollen, it can put pressure on the brain, and that can cause pain and other things.
Your brain's already in a lot of pressure. It's like crammed in your skull.
Andrew, do you have something
I was
else?
also saying that it's antihistamine that's produced. They're antihistamines because histamine was produced in the brain and those pills took it away.
Yeah. Yep. Chelsea?
When you have a headache, like what is it doing to your head?
Yeah, it depends. Headaches can be caused by like inflammation, like Andrew's talking about. Like if there's swelling for some reason in a certain part of the brain, it can lead to pain. And things like Advil or Tylenol, even those medicines are anti-inflammatories. So inflammation means like swelling, and so if your brain in a certain area is swelling, it puts pressure, and that can be
That's
painful.
why I take an Advil every time I have a headache.
Yeah, and those medicines they reduce that swelling, and so that's why they hopefully help.
Why don't you just make a little small incision on your head?
That happens sometimes when people have a severe head injury or infection. If their brain is swelling,
An infection.
like an infection of those in their brain. If they have an infection in their brain, they actually might cut a part of their skull out to relieve some of that pressure. So that does happen sometimes.
I don't want to have
A concussion that's another great question. So concussion,
Isn't it when the brain like
Shuts
hits
down.
against your skull too hard?
yeah, so a sudden jolt can cause your brain to basically hit against the inside of your skull, your cranium, and cause damage or bruising, for example. And that can lead to a headache, difficulty remembering things, depending on how intense it is, difficulty remembering things, or nausea, headaches, things like that. And so we're very much more aware of concussions today, especially in terms of sports. So if you play any sport, you may know like all coaches are trained in concussion protocols. Because if a person gets a concussion and then, well, they still haven't healed from that concussion, if they get another concussion in that time, it can be really dangerous for them, for their health. And so that's why
That's why they
coaches are trained, and you're told if even if there's a potential that you got a concussion, you don't go back into the game because another injury could do permanent, long-lasting effects. And this came up right this year in like the NFL with the Miami quarterback.
It was that guy who fell.
He got
Tua Tagovailoa.
yeah, I was playing the Bills, right?
He had a concussion, and then he played. He didn't listen to his coaches when he got tackled. The back of his head hit
Yes.
the turf, and he got knocked out.
Well, now in the NFL, what was weird about that in the NFL, they have special doctors. They're not like the employee of either team. They're kind of like a neutral doctor. And so if they suspect that you get a concussion, you have to go to them. And if they say you had a concussion, you cannot go back in the game. Apparently, in that situation, he did that. But the doctor said he did not have a concussion, and that's why he was able to go back in the game. But if you saw that football game, like he was clearly not okay. He was like stumbling around, but for some that was controversial when it happened that they allowed him to go back in the game.
You ever heard of a lobotomy?
Also, repeated injuries can build up over time and cause long-term effects like cognitive decline, dementia, and there's a lot of NFL players or even sometimes soccer players, which after they retire, as they're getting older, have serious effects because they've had multiple head injuries over their career, and that leads to a whole. And so there's studies about how to avoid this and how to handle it, how to treat it, how to make sure it doesn't happen, because it's a serious issue with contact sports.
You heard of it?
What's that? You could if you had that. That has happened. I used to show videos about a young high school football player. He got hit. He was a quarterback. He got sacked and had a bad concussion. He went back in the game. He came out of the game, but then he went in the next week before he had recovered, and he got hit really bad again, and he went into a coma. He eventually did come out of it, but his speech is impaired, his memory was impaired, his personality was different than when he got the injury. So yeah, that can happen.
Just one more thing, I guess.
Well, we're gonna get there in a. Yeah, Mr. Professor?
I suppose this is more for anyone interested in psychology, but are we going to get into the story of Phineas Gage?
Is he the guy who lost his memory?
We are not really. Phineas Gage was it's a famous example of brain and things like that. Phineas Gage, I don't know. It was in the late 19th century, I think. Was working on the railroad.
Oh, the spike went his eye.
So he was to blast out the area for to run the tracks. They would drill a hole, put an explosive in there, tamp it down with a metal rod, then move away, explode it to explode the rock. While he was tamping down the gunpowder, it exploded. A huge metal
spike.
Yeah, spike basically blew out of the ground, went underneath his
eye.
This orbital bone, went out the top of his head. He temporarily lost consciousness, but basically regained consciousness pretty quickly. He went back. The doctors look at him. The bleeding eventually stopped. He didn't die. He didn't have any serious health consequences, but people that knew him said that his personality changed completely. After he had this injury, he was almost like a different person. He was mean. He couldn't hold down a job. All of these different sort of personality things happened due to this head injury. And so, like when I talked about scientists understanding like what part of the brain does different things, often they learn that by looking at people with brain injuries. Aisha?
How come some people when they like stab in the brain with a shot in the brain that they survive?
It really all depends on what parts of the brain are injured and how badly they're injured. So a person that has any kind of head injury, brain injury, like if it's small and limited, they might just lose the use of a certain thing or some certain capacity. But if it's a large, massive injury, then it could lead to death. So it just sort of depends on where and how much of the injury there is. Other brain and nervous system diseases, a stroke. A stroke is when basically a person loses a flow of blood to their brain temporarily. And as we've talked about many times, all cells, including our brain cells, they need a supply of blood. They need a supply of oxygen. And so if blood flow to a part of the brain is cut off, that part of the brain basically dies. And so after a person has a stroke, they might see different types of impairment. They may have difficulty talking. They may have difficulty with coordination or moving or memory or all sorts of different things. And again, it all depends on where that damage happened in their brain and how extensive it is. Polio is a disease that once affected millions of people throughout the world, and it is a nervous system disorder. It led to paralysis. It led to muscles sort of wasting away. It can make people unable to walk and have to be in a wheelchair. Today, there's very little polio
Vaccine.
because of vaccines. Polio was one of the first vaccines that was used widespread, and it basically almost wiped out polio across the world in a matter of a relatively short time.
Kind of like COVID.
Parkinson's disease is another brain disorder that's caused by a lack of a special chemical, a neurotransmitter called dopamine. Leads to people having tremors, meaning sort of spasms and difficulty with walking or other motor availability. Yeah, like some people, like my daughter has a tremor in her hand. If she reaches her hand out, it kind of just involuntarily shakes.
That's what means.
Yeah, hers is not caused by any specific disease, and we took her to a neurologist, a doctor that studies the brain and those things. And some people just have this, and it doesn't affect her very much. She has this sort of shake. Sometimes it goes away, sometimes it doesn't, but it's not an indicator of anything else that's going on. It's just something that she has.
Can you like develop it?
It can develop, and it also can go away. So sometimes it can just sort of start, and it can then eventually go away.
Cool.
So it just sort of depends on what the causes are. But it's definitely something like to check out, because there could be other causes. It could be something else that you would want the doctor to know about. Yeah, Jordan?
What's it called when like when you're like looking at something and like one of your eyes like drift off?
I don't know.
Head in the clouds.
No, just like your eyes don't focus on the same thing. Yeah, I don't know what that's called
ADD.
exactly. No, but sometimes that does happen. That it could be due to muscles in the eye. Like muscles control how our eyes work together, and so sometimes a muscular thing could cause one eye to sort of lag behind the other or drift off, or it sometimes could be like the nerves telling the eyes how to move might be impaired.
Oh, this one's my favorite. Alzheimer's.
Alzheimer's
Forget.
is a disease again that leads to it slowly the buildup of of things in the brain that interfere with normal brain function. Like my grandmother had Alzheimer's, that's what she died of.
She just forgets everything. Like
Not
How
everything.
are you?
So my grandmother, she had Alzheimer's. So she did, like, over time she got dementia. Like, that means like confusion. And what's weird is that some things, like, she would forget that would forget very easily what she had for breakfast or what she had for lunch, or sometimes who her children, which child was which. She was in her 90s, but she could remember very, very clearly things from her childhood. She could remember going and walking to school on James Street and walking to school and meeting her friend. Like, there's very specific memories she was for some reason able to hold on to, but she had difficulty making new memories. And over time, Alzheimer's leads to sort of this gradual decline.
Sad. Like you lose everything that you ever loved in your brain.
Tom? Yeah, Mr.
Well, we're not adding to what you said, Luke, we're not talking about just forgetting who your loved ones are. Eventually, we're talking
You're an empty
forgetting
shell.
forgetting you have to eat, forgetting what I have to go to the bathroom feels.
Yeah.
like.
Yes, and often, usually, it progresses. It gets worse and worse over time. It happens at different rates, and some people go on for a long time and are doing okay. Other people have a more rapid decline. It just sort of depends. And the causes of Alzheimer's are still a little bit undefined. The scientists don't exactly know why some people develop it, why some people don't. So it's kind of
And there's no cure.
there's no cure either. You
There's treatment.
you could treat people or do like therapy to help people deal with. Same thing. There's no cure for Parkinson's disease. Like, people that have it go for physical therapy and do other things to help them cope with the symptoms, but the disease itself can't be cured. Epilepsy is another neurological malfunction when,
You see flashing colors and you spasm.
well, sometimes some things can cause a person that has a risk for it to have an epileptic seizure. And so sometimes you'll see in like video games that might say this video game contains flashing lights or patterns, because that does trigger sometimes people that have epilepsy or tend to have seizures, that certain patterns can trigger them to have one. So that's why those warnings are there on video games and movies and things sometimes. And epilepsy is when the neurons that control our movement in the brain fire just sort of randomly. And it can lead to a person having a major seizure where their body is sort of uncontrollable, where they have, very large movements.
It's flailing around like
But there could also be epilepsy when a person has very unnoticeable seizures, where to somebody from the outside, it just looks like they're kind of unfocused, or they might just close their eyes. But that's a different type of seizure that sometimes affects people too. What's that? All right. So there's a lot we could talk about related to the nervous system. So you guys are going to be doing an activity here in a minute.